just have a look at this video, and what I want you to think about is what maths can you see in the video. We're doing a mini project which is part of our APP process and is essentially an in-house kind of rich task that we've developed with the idea of trying to get a better idea of where students are. A rich task is the sort of activity where there's a number of paths that the students can take and it can lead them to different answers in the end. APP, because of the fact that if they can explain to me that it's 180 degrees in a triangle, they're showing me a level 4 skill there, essentially. And verbally is enough for me. They've said it to me, so I know they've reached that point.
Whatever angle that is there, then it's going to be the angle that is bouncing off that. AA.
The bouncing around that the students kind of do in the first lesson is all about the conflict they're having. There's a conflict behind kind of them coming up with ideas and not being sure if they're correct. And so there's a confidence building kind of element there. The bouncing around is experimenting, seeing what works, what doesn't, making hypotheses about what they think is going to happen, and then trying practically to see. What if we didn't know what that angle was? What if that angle was N?
You'd work it out.
If a student gets kind of stuck and pinned down by a concept, I'm quite happy to let them battle with that concept for the hour, and maybe they don't get miles into the mini project, but because we're doing this over and over again throughout the year, we're going to get a picture in other places. Okay, Adam, tell us what you're doing then.
10 plus 80 equals 90.
Right.
40 plus 50 equals 90.
Right.
And I found out the nth term. So the nth term would be n plus 90 minus n. That would equal 90.
Fantastic. Now, what I'm really interested in here, okay, is that you've been going around and you've been changing the angles, which is absolutely fantastic. But now you're starting to think about, what if I don't put a particular number down, but instead I put down n? Could you try drawing out your diagram, but instead of putting numbers in that diagram, could you try putting those angles that you've started there? Because you've certainly started it, but it'd be nice to see it in a diagram, and then maybe I'll be able to see what other kind of patterns is coming out from that. That's fantastic. Heading into algebra, absolutely brilliant. That's where I want you to head. I'm holding back very much, so I'm just trying to push them in the right direction when I can. But at the same time, if I can, what I'm trying to do is get the students to explain to each other what's going on. So if they ask me a question, what I'll often do is defer that question to somebody else on the table. Okay, good. So you've noticed that there's a pattern going on here where you've got this alternate going on. And you've also noticed that n plus a equals 90.
So, you know, this is Adam's method.
Right.
I think it's like the same as mine, because you've got n plus here, and 90 minus n is another number. If you could just call that A.
Oh, this is really interesting, because what you're doing there, right, and that's absolutely fantastic, okay, is you're doing what's called algebraic substitution. Okay, so you've noticed that this actually looks the same as this. Yeah, and look, you've taken that 90 minus n, you've said that really is, that's great stuff. That's really high level algebra that you're doing there. I'm really, really impressed.